we had our 5 properties from yesterday. So we learned yesterday that a parallelogram has the opposite sides on the parallelogram are always going to be parallel. So we draw our parallelogram. We know those opposite sides will always be parallel to each other. We know the opposite sides are always going to be the same length. They'll always be congruent. We learned that the consecutive angles are supplementary. What does the word supplementary mean again? Adds up to 180. So our consecutive angles, those angles that are next to each other, those will always add up to equal 180 degrees. And by that same logic, we were able to use that to learn that opposite angles would have to then be congruent. So those opposite angles, your parallelogram will always be equal, and then your adjacent angles will always equal 180 degrees. And then the last thing we talked about yesterday was about the diagonals. So we learned yesterday that if you have diagonals of a parallelogram, that those diagonals bisect each other. The length of those diagonals, when they cross, are exactly the same on both sides of that intersection. So your left side is the same as your right side, and the top side is the same as the bottom, but those walls. So these were our 5 properties we talked about yesterday. These are the 5 things we learned yesterday. So the main thing we're doing today is just learning how can we use these properties in whatever situation we're facing. Not worrying about the proofs or anything like that, just using these properties. Sound good? All right. So we're also going to come into a situation where you're going to be given a quadrilateral, and we have to determine, is this quadrilateral a parallelogram, or what would allow this quadrilateral to become a parallelogram? How can we satisfy one of those properties to make this a parallelogram? So, looking at this picture, what do you notice? We have diagonals. So what do we know about the diagonals of a parallelogram? They have to bisect each other. So in order to make this shape a parallelogram, we know that these diagonals will need to bisect each other. So we're going to have to figure out what numbers for x and y would allow this to make these diagonals bisect each other, would make those values true. And so once again, the definition of bisecting, it means that on each half of that intersection, both those halves will be equal to each other. So if we can figure out what value for x and y would make those halves equal to each other, then those are diagonals will bisect each other, and then we will have a parallelogram. So in order to figure out what x and y are, all we have to do is just set these sides equal. So 3x, we need to figure out when that is equal to 4x minus 5. And we need to figure out when 14 is equal to 2y. If we figure out these values, then we have our answer. And from here, it's just some simple algebra. So in order to solve for x, what would I need to do for this problem? Get both x's on the same side. Which side do you want to get them on, the left or the right?
You want to subtract your x to 4. You want to do the lower number.
Alright, so we'll move 3x to the other side. So 3x minus 3x is just 0. And then 4x minus 3x is 1x. So we have 1x minus 5 equals 0. What now? Add 5. And now 1x is the same as just x on the side, and then 0 plus 5 equals 5. So x equals 5. Now, we can hopefully assume that this is the correct answer. If you're ever worried that your number you got was incorrect, what you can do is you can take that number and plug it back into the situation and see if it makes it true. So we're trying to show that this half is the same as this half. So if I plug 3 into there, 3 times 5 gives me 15. So this length is 15. And then 4 times 5 is 20. Minus 5 is another 15. And so this length is also 15. So I know that both these lengths are the same. So therefore, my x must be true. So we solve for x. How do we solve for y? Simple. Just divide the coefficient by 2, and we get y equaling 7. So y equals 7. Plug that back in. 2 times 7 equals 14. Okay, 14 equals 14. We know this is true. And so x equaling 5 and 7 equaling y, those would be the two values for x and y that would make this a parallelogram. So once again, the main important piece is just determining what property to use. The algebra is important, but it's not as important. But the main thing I want you to focus on is which of these properties will help me actually solve this situation. So once again, for what values of x and y would make this quadrilateral a parallelogram? Now, one thing to think about when you see these types of problems is what information are you given?
That the opposite sides are parallel, opposite sides are congruent.
So what information on this picture are they given? What are these equations, or what are these expressions represent?
The side length.
The side length. So what do we know about the side lengths of a parallelogram?
The opposite sides are congruent.
They're congruent. So we know that the side lengths have to be congruent to each other and have to be equal. So that means your opposite sides, we can just set them equal to each other to solve. So 3x plus 5, I'm sorry, 3x minus 5. That's going to equal 2x plus 1. And x plus 2. That has to equal y. How can we go about solving this? But which one are we going to have to do first? Why the left one? If we were trying to right one, we have an x and a y. We can't figure out what either of those are before we solve it. So if we figure out what x is first, then we can plug that x back in, and then we'll be able to solve the y. So good. So we'll have to do the left one first. What would you do on this problem? So we're going to move our 2x over to our left side. Okay. So we'll subtract 2x. And that gives us x, because it's 3 minus 2 is 1, minus 5 equals 1. Last step? Add 5. Simple algebra. So x equals 6. So now that we have x equals 6, we can look over to our other side, plug 6 in. 6 plus 2 equals y. So y then equals 2. Once again, if you're really concerned you have the wrong answers, you can always plug them back in to check. So we could plug 6 back in. 3 times 6 is 18, minus 5 is 13. 2 times 6 is 12, plus 1 is 13. So 13 equals 13, my sides must be congruent. 6 plus 2 equals 8, y equals 8, must be congruent. And so you can always go back and plug it back into the situation, just check and make sure you're correct if you're ever worried that you aren't. But x equals 6, x equals 5. No, x equals 6, y equals 8. And so once again, the main thing is determining, okay, what information am I given in the problem, which of my properties relate to that information, and how can I use it to help me solve it. So which of our properties will help us solve this?
That the opposite sides are congruent. No, the opposite angles.
So opposite angles are congruent, that's what one of our properties we know. Now if we look though, my opposite angles is y plus 10 and x plus 4 is 13, and 3y minus 2 and 12x plus 7.
So it's supplementary.
So we're going to actually have to choose a supplement. So we know consecutive angles are supplementary. So we know that these adjacent angles will have to add equal 180 degrees. And so with this, because we have two properties that deal with angle measures, just check where your variables are. If your variables are on opposites, then you'll want to do the opposite one. If your variables are on the same side though, then you'll want to use the consecutives. And the thing is, what does the word supplementary mean?
It adds 180.
Adds to equal 180. So how are we going to set up these equations?
You need to take your equations and add them, and then say equals 180.
Alright, so we have 3y minus 2, and then I can add my second equation. Y plus 10
equals 180.
equals 180. Good. And same idea with my second one. 4x plus 13 plus 12x plus 7 equals 1. So take a moment, see if you can combine your like terms, see if you can solve these two equations for x and for y. Once again, the algebra isn't as important on what I'm looking for. The main thing is what I'm looking for is what properties are you using, but the algebra we still need to do that just in case to solve. So see if you can solve these for x and y. So what do we find for our y in this situation?
I have 43.
Y equals 43. And then what do we find for x? 10. Okay. So combine your like terms together, inverse your constant, inverse your coefficient, and we get y equals 43. Once again, you can check by plugging these back into your situations and making sure that they actually add together to equal 180 degrees, so that your opposite sides are congruent and all that. And so that would actually help you check whether your answer is correct. If you don't get that, then you probably did something wrong or somewhere in that algebra, and we can check through there. But once again, if you have the same side, use those consecutives. If you have opposite variables, use your opposite angles. But it all falls back on which property do you want to use. What should we do?
Opposite angles are congruent.
Opposite angles are congruent? All right, how would you set that up then?
X plus 17 equals 2x minus 21.
So x plus 17 equals 2x minus 21. Okay, and your other one?
13y plus 8 equals 18y minus 37.
13y plus 8 equals 18y minus 37. So good. So remembering what the definition of congruent and what the definition of supplementary as well. Make sure you keep those straight. And in supplementary, you need to set them or add them together to equal 180. If they're congruent, you just need to set them equal to each other. So depending on which property you do, you might have to set your equations differently depending on the property. Okay. So from here, all we have to do is solve, and then we can figure out what our x and y is to make this a parallelogram. This should be our last question today. See if you can get this. What did we find for our x's for this situation? 38. X equals. And once again, in order to check, you can plug x back into your situation. So 38 plus 17, whatever that number is, 55.
Yeah.
55 degrees. And we can check to make sure that's the same as 2x times 38 minus 21. That also gives us 55. Okay, we're good. What do we find for our y?
9.
9. Y. And once again, same idea. If you wanted to check just to make sure, plug 9 back in for your y in your situations, make sure they're the same number, then you're good. Are we okay with this? Once again, the algebra isn't as important on what I'm looking for. I'm looking for what properties you're using. So which of the properties did you
You don't
use?
have to say.
I'm debating that. I probably will just because I want to see what your thought process is. So I'll probably have you write down, say, problem. I'll let you know before the quiz like, whether I'll have you write it down. I'm still deciding how to do that. So I have like a fill in the blank or like a short answer like opposite sides are equal or opposite sides are parallel or something like that. Whatever property you end up using, I'll figure it out. So we have those 5 properties, but there's actually one other way to show that parallel or quadrilateral is a parallelogram. It's kind of like our hypotenuse leg of our congruences that we talked about in the past. So we had like our side 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 or angle side side, and then we had like hypotenuse leg, which was sometimes used. So we have this additional corollary, which is like sometimes used. It's not used as often, but sometimes it shows up. So if you have a quadrilateral, if the opposite sides on that quadrilateral, just one set of opposite sides is congruent and one set of sides is parallel, this is enough information to show that you have a parallel. Typically in the past, we've had to show that both sets of sides were parallel or both sets of sides were congruent. But if you show that just one set of sides is parallel and congruent, that is enough to say it's a parallelogram. It's a little bit weird. It doesn't come up as often, but it is a possibility that sometimes comes up. And so it can be helpful just to know this is an additional corollary. And so situations where you might encounter this. You might run into a quadrilateral. Is this a parallelogram?
Yes.
How do we know?
And the sides.
So we have a set of same sides, and because both of these add up to equal 180, then we know these lines would have to be parallel. And so you have a set of congruent sides that's also parallel. So yes, that is enough information by that corollary to say that this is a parallelogram. And so it doesn't come up as often, but it is a possibility that sometimes it will be something that you'll need to use. But the more important things that you'll want to focus on, what are those 5 properties? What about this? Is this a parallelogram?
No.
Why not?
The sides are the same.
Yeah, the sides are not the same. So we have 11.6 and 11. Those are not equal to each other. And so, every parallelogram has to have equal sides, so this cannot be a parallelogram. Another thing you could look at is 35 plus 146. That does not equal 180, so therefore it is, I think it actually 181. It's like close, but. And so this is no parallelogram. So as long as you would notice one of those two things, that would be enough information to say, like, no, that's not a parallelogram, and then you'd be done. What about this? Is this a parallelogram?
Guys. The guy.
So what do we think? What do we know about parallelograms? Quadrilateral. Yeah. They're parallel sides.
Same side. Yeah, that isn't.
It does have 4 sides. What do you know about the side lengths of a parallelogram? What are they called? Which sides? Opposite sides.
Those are not opposite sides.
Our opposite sides on this one are not congruent. These are not congruent, and these are not congruent. They're congruent to each other on the adjacent sides, but the opposite sides. So this would not be considered a parallelogram. This is our type, though. It's a type of special quadrilateral, and sometimes shows up, but it's not as important. It is not a parallelogram. So this is not one of our special parallelograms. What about either of these? Can we prove either of these are parallelograms?
Yeah.
What are your thoughts?
Because those two opposite sides are parallel, and then those other ones are the same.
Do we agree with this? So this is actually kind of like a trick question. So if we think through our corollary, in order for this to work, it has to be the same set of sides, has to be congruent and parallel. Otherwise, it doesn't work. So with this, because we have a set of parallel sides and a different set of congruent sides, it could be a parallelogram, but we don't actually have enough information to actually say it. It doesn't quite meet our corollary, and it doesn't give us enough information to say that these two sides are congruent or these two sides are parallel, so we can't actually meet any full properties. We don't have enough information to say it's not a parallelogram, but we just don't have enough information to say what it is. So for right now, it could be, but it also could not be. And so we can't technically prove that it's a parallelogram. What about the second one, though? Why do you think so? Just taking a guess? So, what is that line going down the middle? What do we call those?
Reflexive property.
So if we're thinking about congruent triangles, it could be a reflexive property. Or a diagonal. If I'm thinking about parallel lines, what do we call the line down the middle? Parallel lines.
The metal.
Started with the T.
They'll like stop them from doing
Oh, transversal.
Transversal. So this is a transversal. If you think about these two as parallel lines, and this is your transversal, what do we call these types of angles?
Like your angle pairs or your
What type of angle pair would it be?
alternate interior.
Alternate interior angles. So by alternate interior angles, if I have congruent angles here, then I know that these lines would have to be parallel. Same idea, if I turn my head to the side, I have alternate interior angles here across this transversal. So that would make these also parallel.
So yes.
So yes, we do have a parallelogram. So you have 4 sets of parallel sides. Now it's a trickier one because you have to sort of like think what are those angles actually helping you with. But yes, that is a parallelogram. So the main thing to focus about today is how can you use those properties that we talked about yesterday? How can we use those situations to show whether this is or is not a parallelogram? Or how can we use it to set up an equation to find what those values would be to make this a parallelogram? And so, once again, the algebra isn't as important as what I'm looking for. The main thing is, what are your thought processes? What are you doing to apply this? And so I'll figure out how I can make it more thought process oriented rather than algebra oriented on the quiz. But then again, you also still have to know your interior angles on the right as well. But tomorrow we're going to talk about what is a special type of parallelogram. So we have a couple special types of parallelogram: our rhombus, our rectangle, our square. Those are all parallelograms, but they're all unique in that feature. And so we'll talk about what makes them unique and how can we tell whether they're unique. And then on Thursday and Friday, we'll practice for our assessment on Friday. Sound good?
Yes.
Sure.
All right.